Alright folks, now it's time for the math object. The math object. So I'm going to get rid of all of this date object related code, and we're going to talk about the math object. The math object, or rather the math function in JavaScript, is used for a variety of different functions. But its most useful is in generating random numbers. We can do a number of things, perform a number of methods on the math object. The math is a universally recognized object in JavaScript. And we can perform on this object a number of methods like ceiling, floor, round, random. Okay, these are a couple, and these are the most important for the topic of today, and these are the ones which I'm going to teach you how to use. So let's start with what should be the easiest one, Math.round. First of all, you should be asking yourself, what do these methods take as arguments? Can I simply execute Math.round in my console and expect to get a meaningful result? No, not really. I don't know what this math object is yet, but there is nothing tying whatever functionality is happening here to a specific value that has meaning to me or significance to me. So you should be asking yourself, what goes in those parentheses? Well, the answer is, as you might expect, a number. And what Math.round does is it rounds that number to the nearest whole integer. So, basic rules of mathematics. If you have a decimal, if your decimal value is greater than 0.5, it will round up. If it is less than 0.5, it will round down. As simple as that. There is nothing sneaky about Math.round. Okay. Next we have Math.ceil, short for ceiling. This also takes a number. The only difference between Math.ceil and Math.round is no matter what, Math.ceiling will round up. Okay, it doesn't matter how small the value after your decimal is. Math.ceiling will always round up to the next whole integer. Okay? And next we have Math.floor. Math.floor is the exact opposite in that no matter what the value after your decimal is, Math.floor will always round down. It will always round down to the next lowest whole integer. Okay? Hopefully that's straightforward enough. Math.round, Math.ceiling, and Math.floor. They all kind of work in tandem. They all perform collectively the same function. Round speaks for itself. We all know how to round numbers from elementary school math. Ceiling and floor simply round numbers in a stricter way. And as long as you don't ever get them confused, you should be completely fine. Finally, there's Math.random. Math.random does not take an argument. Unlike Math.ceiling, Math.floor, Math.round, Math.random doesn't take an argument. It doesn't need one. I can run Math.random as many times as I'd like, and it will always generate a number. That's what Math.random does. It generates a random number. But I need to ask you, I've now executed Math.random a couple of times. Do you see a pattern in the numbers that it is generating? This is no great statistical feat. This is no skill requiring data analysis. All I'm really looking for from you is that all of these numbers are less than 1. They're all less than 1. And they're all greater than 0. So what does that tell you? You're in week 12 now, so you need to start thinking more aggressively about how to learn about new methods, how to learn about new functions, new objects, new properties. And what does it tell you that the number, whatever number that may be, which is generated by Math.random, is always greater than 0 and less than 1? What does Math.random do? Math.random generates a random number between 0 and 1. I could have easily looked this up, and all of you guys should look something up anytime you see something new, but you also should test it. You should try it out. You should see it in action. You should never shy away from testing and using something you're not intimately familiar with. Anyway, Math.random generates a random number between 0 and 1. Okay, and we're going to use Math.random in a couple different ways. How would we use Math.random to, for example, generate a random number between 1 and 10? Can we do that? If Math.random simply generates a random number between 0 and 1, how can we use it to generate a random number between 1 and 10? Well, what if I do this? Math.random times 10. What does that give me? Well, it's much closer, right? The only exception so far has been this 0.268064, blah, blah, blah. So there's still something going on there, something that we can't control. So let me rephrase my question. How do I generate a random whole number between 1 and 10? Well, let's try something like this. Cool, that works. That works great. Okay, so we now use 2 math object methods in order to generate the range of numbers that we're looking for. Question is our range perfect? Let me see, if I keep running this, there it is. There it is. You see that 0 there? That 0 is not supposed to be in our range. We want to generate a random whole number between 1 and 10. That is not inclusive of 0. So how do we fix that? What do we do about that? I can tell you right now, there is no way to prevent .random from generating a certain number or a certain range of numbers. It's always going to generate a random number between 0 and 1. You can't tell it that if a number is between 0.001 and 0.1, then generate a new one. You'd have to use additional functions for that. And while that logic would work, and you could try it, it gets a little bit verbose. There are easier ways to do it, albeit not necessarily the clearest ways right off the bat. They can be confusing when you're just starting to learn about random number generators. So what if instead, get rid of these, I do this. Math.round, Math.random times 10 plus 1. It doesn't really sound right, does it? It doesn't really seem right, but let's give it a try. So far, so good. No zeros. Got a 10. Oh, there's a 0. Oh no, this is the wrong function though. Sorry guys. Alright, well, looks like that works for our range. So let's break it down. Let's figure out why it works. Math.random is going to generate a number between 0 point something like 0.00000001 and 0.999999999. Okay, so if we just had Math.random in here, what would they round to? It would round to 0 and 1, respectively. The lowest possible number generated by Math.random and then rounded, and the greatest possible number generated by Math.random and then rounded. If we throw in times 10, well, then we get 9 times 99999 and 1 less 0 here. What do they round to? 0 and 10. 0 and 10. Math.random times 10 rounded is going to yield a lowest possible number of 0 and a highest possible number of 10. So far so good, but we want to make sure that 0 is not in our range, correct? So we take the product of Math.random and 10, either of these two numbers, any numbers in this range, any number between these two numbers, and we add 1 to it. So what does that do to our range? Well, it changes this lowest possible number to, and these numbers, again, they represent the argument, which is being rounded. Okay, so this lowest possible number becomes 1.00000001, which rounds to 1. And this number, the highest number in the range, becomes 10.9999999, which rounds to 11. And therein lies the problem. We have effectively cut 0 out of our range, but we've now included 11 in our range inadvertently. That's a problem. And the problem, the place where this problem is coming from, is not the logic in here. It's actually .round. Put it another way, what happens if I replace Math.round with Math.floor? Well, if I execute Math.floor on this number, what am I going to get? I'm going to get 1. If I execute Math.floor on this number, I get 10. And that is the range that we're looking for. Math.floor on Math.random times 10 plus 1. Okay, that's the problem solving that I would have gone through, that you should go through, should practice going through when constructing a random number generator that needs to generate whole numbers within a specific range. It's a very common thing, and I'll address what that might be used for in a bit. But this is the problem solving process. And you got to be careful, because in all those numbers that I generated in my console, I never actually got 11. So it would be easy to fool myself into thinking that without this plus 1, we're set, we're good to go, we're okay. Or actually, with this plus 1 and with Math.round, all is well and we're okay. But that's not true. There's still the possibility of getting that 11. So you need to actually think, what's the lowest and the highest possible number generated by Math.random. Therefore, what's the lowest and highest possible number generated by Math.random times 10? Therefore, what's the lowest and highest possible number generated by Math.random times 10 plus 1? Therefore, what's the lowest number in my range possible and the highest number in my range possible? We went from 0 to 10 to 1 to 11 to 1 to 10. We arrived at the right range in the end, but it took some problem solving and some steps to get there. And all of this is easily understood if you can understand that Math.random generates any random number between 0 and 1. It does not include 0, and it does not include 1. Okay, I know it feels like a lot, or some unnecessary complexity, but it's truly not. It simply takes a little bit of practice, and you'll see Math.random is not complicated at all. There's no excessive mathematics that we're practicing here. Promise. Okay, so that got us to the correct range. We need this to be Math.floor. And this is usually a pretty tricky concept for students, because why would we use Math.floor? As human beings, we're so used to Math.round. It seems so much more sensible to use round. But for better or worse, this is the best way in JavaScript for generating a random number in a specific range. And the formula for this is as follows. Math.floor executed on Math.random times your maximum number minus your minimum number plus 1 plus your minimum number. Okay, if this feels like a complex formula, it's only this reason because it accounts for every possible scenario, every possible range of numbers. This formula is going to work for you. So it's a good one to know, but don't feel like you need to memorize it. I frequently forget it and just end up looking it up again, and in 10 seconds I find it. It's very easy to find with a Google search. And also, if I really had to, I feel like I could figure it out again on my own if I had to. But again, Google is your best friend. You do not need to memorize this formula. It should look familiar to you. You should recognize it when you see it. But this formula will help you to generate any random number in any random range of numbers you could ever need. So if we applied it to our range of 1 to 10, what would that be? Math.floor of Math.random times 10 minus 1 plus 1, so 10, plus 1. That's exactly what we have up here. Our parentheses are a little different, but the order of operations keeps it all the same. If you're confused about why we have max minus min plus 1, well, you're not always going to start from a minimum range of 1. Let's say we wanted to generate random numbers between 50 and 100. We would need Math.floor times Math.random times 100 minus 50 plus 1 plus 50. So what would this be? This would be 50 plus 1. 51. We don't want to add these two together because we want this to execute first and then this product to be added to 50. So you don't need parentheses here because of, please excuse my dear Aunt Sally. Anyone remember that mnemonic device from elementary school? But if you insert the parentheses, it's not going to hurt anything. Okay, so that is the math object. Now, the next question, the follow-up question is, why would we ever need a random number generator? Especially if we're not working on some esoteric data visualization or anything like that. Well, my response to that is, have you ever used the shuffle feature on literally anything? Have you ever used the shuffle feature on your Spotify playlist, on your iPod Nano back in the day, if any of you are old enough to remember iPods? If you've ever used the shuffle feature, no matter what the platform, the product, the device, that shuffle feature is driven by a random number generator. It's driven by a random number generator. Okay, now don't say, oh, that's cool, I get it now, and move on. I want you to stop and I want you to think, well, what role does the number, which is randomly generated, play in a device that uses a shuffle feature, or a feature that uses the shuffle feature? Where does that random number come into play? What role does it serve? And the answer is that random number serves as the index of some array somewhere, which indicates which song will be played next, which image will display next, which episode will come on next. Whatever it is that you're using the shuffle feature for, the random number serves as the index of the next item to come up. Okay? So I hope this has been helpful. Again, don't memorize this. Just take some time to look at it, take some time to recognize it, and please practice it on your own. Try to generate random ranges of random numbers on your own several times. It's the best way to get comfortable with using these methods.